All right, guys, we are live. Hi, I'm Mohit Yadav. I teach at Scalar. I have been working as I have led teams at Hotstar and Nutanix where I got a chance to build massive scalable products. The pipelines out of that I built scale to 1 terabytes of data per day. The API was able to scale for 10 million users. So that's my background. We have other guest with us, who's Arnav. Arnav was basically the founder of Coding Blocks, and he heads mobile department of Zomato. Right. So both of us are here today to talk about how do you debug applications in production, right? And we'll give both perspective this time. We'll talk about front end and client side, and we'll also talk about backend. Right. And for that, we launched a couple of polls on Discord and our Telegram channels to identify what are the major issues and what are the major questions that are coming up, and we've sort of added them on the right side of the chart if you look at. So we'll go one by one or over each question, and if you have any other question as well, please feel free to add them in the comments. We'll keep on taking the question one by one, and we'll give our perspective, both from the front end and the back end side, right? So let's get started. The first question that we sort of want to talk about is, so what are some of the key points we need to take into consideration while designing applications? Anna, do you want to take it like talk about the client side first, and then maybe I can give some backend perspective to it.
Sure. So that's basically like keeping the broader theme in mind that how to debug in production, how to make things in such a way that it's possible to debug in production. In that angle, I'm just answering about design. So there are a bunch of things. I think the most important thing is obviously having monitoring and alerting in place before you go to production, before your product is up there with millions of people. So there are actually a bunch of things there. When we talk about monitoring as well. So one is that your crash reporting framework. So that sort of Firebase and crash statics have almost become a de facto standard with mobile apps at least. With web frontends, in fact, by the way, Firebase can be used with frontends for crash reporting as well. But there are other frameworks like Sentry and all also exist. So that's basically your whenever some crashes happen, you have the logs for that, and you have the stack traces for that, and you should be able to sort of trace exactly why that happened. There, one caveat or one more thing is very important is that you should have your source mapping properly set up. So basically, uh, for web frontends, you generally minify your code. Your JavaScript code gets minified, so your variable and function names are all mangled. Similarly, when you are on iOS or on Android development doing that as well, then also you're obfuscating your code. Again, same thing happens. Your symbols, variables, function names, they're all mangled again. So you should have like a reversing those back to your actually so that you can map to exactly which line of source code, which function actually crashed. The source maps need to exist. You should have the source maps properly in place with your crash tracking framework so that the stack traces make sense. Otherwise, the stack trace will come and you won't be able to make sense. That's about the crash part. The other part is user behavior tracking also needs to be there so that you can sort of recreate the exact way the user reached that particular place. So there are a bunch of things. The click streams are there, which is you basically log what all IDs of entities in the screen, buttons and cards and all, which the user clicked one by one, and there is log of that. And there's something called breadcrumbs. So breadcrumbs, like generally every page transition that happens, we generally drop a breadcrumb. Breadcrumb is basically just a log line that okay, this activity opened, this fragment open, or in a web app it would be like this root got changed slash articles went to slash users, something like that. Okay, so breadcrumbs are dropped. They help you recreate the user journey, how they reach that place where that sort of happened, right? And then for the for product people, for analytics people, we set up things like ELK or Kibana based things for just collecting the logs as well. Those things also need to be set up. That's about basically the monitoring part. Another thing that when you're designing applications, I feel very important is the it's going to be running on your user's device, not on your device. It's a client app that will be running on a browser or mobile phone. Resources could be scarce depending on what kind of device that person is using. Right? So properly profiling memory and being able to detect memory leaks wherever those are happening, reporting on that should also be available, so that you can keep track of the fact that if there is some resource bloat that is happening on your apps, and that will put off a lot of people, that this app or this website slows my computer down, or when this app is open then other apps are not able to work, things like that. So being able to monitor your memory profile is important. And finally, one very important thing, which is not really about debugging as such, but general performance, I would say, is that working with these days you have got streaming HTTP responses using HTTP 2.0, where before the entire response has come, you can start showing something on the screen, or you can use compressed API response. There is gzip available, and there is an even newer one Google has made called Brotli. BROTLI. It's a compression scaling. So those, using compressed APIs, those are important. Wherever you're using images on the front end, again, probably having a separate URL for thumbnail, which you can first download, 1 KB, 2 KB size thumbnail, and then download the 200, 300 KB sized actual image, so that there is a okay-ish looking placeholder before the actual image is downloaded. Progressive loading of images, we basically call. Those kind of things are sort of set up properly. Pagination of your APIs, again, those things are needed. So I think roughly keeping these things in mind, I'd say are important when you're designing for the front end. Off to you, like what do you think are sort of important steps for the backend?
Yeah, that really helps. So I'll also start with the same monitoring setup, right? So I think irrespective of whether it is infra issue or a client issue or a backend issue, one thing that really is able that really helps in debugging is the kind of monitoring metrics that you've set up. But in on the backend side, it's primarily on the percentile metrics, right? That how many percent of your users are able to get a response within X amount of time, or people typically measure average latencies, or maybe what is the mean latency. But if I have to extend it, right, I want my 99% of my users to be happy, or maybe 99.9% of my users to be happy. So measuring these matrices, like in terms of response time, and how many 4xx are coming, how many 5xx are coming. If the 4xx are alarmingly high, I just go and check whether I'm getting lot of unauthorized or forbidden kind of 403 kind of errors. That means that that will give me a hint of attack, right? A person is basically trying to game my system, because I'm getting lot of forbidden error. If the just imagine a scenario where 50% of the users are or 50% of the requests are translating to 4xx errors. That is a hint to you that it is an alarmingly high number. Maybe somebody is trying to game your system. Bump up your infra security team can be alerted based on that. If the number of 5xx are really high, so typically always look at the kind of HTTP response that you are getting and log it. If that response is alarmingly high, then raise an alert. So this brings me to the second point. After you have captured all the metrics in monitoring part, you raise an alert. Alert can be automated, right? In automated alerts, you can typically one type of alert can be that hey, my CPU utilization for one server is really getting high, so I might want to add more instances because the kind of request that this particular server can handle, it's no more able to handle those many requests. So I might want to add new instances. So this is an automated trigger and automated resolution as well. Similarly, if the CPU utilization, for example, is very low, that means there is no very little load on my system, and I can typically decrease the number of requests. So decrease the number of servers. Sorry. So these are automated kind of responses or automated checks that I can have. Then there are unautomated checks or which would need manual intervention as well. Those kind of checks would be, for example, the security vulnerability that I pointed out, right? So if you're getting a lot of unauthorized access, that means you need to maybe tell a person that, hey, this is something unusual. Please go and check, have a look at it. Why is this kind of error? It might be due to maybe the API function. I've changed the API token, but my clients have not, I've not sent that token to the client, and they're still sending the wrong token or wrong salt key, due to which I'm getting the error. So it might be due to a bug as well. So net, this is where a manual intervention would be needed, right? So classify your errors based on whether you can resolve them automatically. If not, have an alerting mechanism. Alerting mechanism should be such that the team who's responsible for that particular error is alerted, right? Not everybody in the team would be able to debug a security issue, for example. Or if it's a particular microservice, then you might want to alert the person who's written that particular microservice or who's the owner of that particular product, right? So those are the typical things on the monitoring and the alerting aspect. Another important aspect when it comes to debugging is distributed tracing, right? So I'll explain you what I mean by distributed tracing, right? Imagine that you have designed a homepage of a website like Netflix or Hotstar, right? There, if you notice, you see a lot of personalized content, and then there are promotional content as well. For example, if GOT is releasing, I'll probably push GOT recommendation, even though whether or not you watch English TV series or not. But since it's a new release, I have to place that content in your homepage. So typically on the backend side, how it's done, it's from the UI, it will call just a single API, right? It can be a backend from frontend. We'll go into that aspect as well in the later part of the discussion. But assume that the entire homepage is getting fetched from a single API. In that case, to get the response of that particular homepage, you would need to call multiple microservices or multiple services. One would be giving the recommended content, one will be giving you the editorial content, and it becomes, and let's suppose you get one user gets an error. How would you go and debug this? The problem in debugging, what I'm trying to highlight over here is that that particular request is flowing through multiple systems, right? And let's say the exception occurred in the recommendation part, you would not be able to trace what was the original request, because the first system gets a request, goes to two systems, and this system got an error. So error is here. You don't know what was the request, what does the request look like in the other systems, right? The first system or the second systems. You need a system which can uniquely identify every request that is getting added to your particular system. And this can be easily achieved by adding a unique ID or a UUID in your with every request. So what typically people do, I'll just explain briefly what distributed tracing is and how it works. So what people typically do is, as soon as the controller in the application gets a request, the API controller, the REST controller that you've exposed gets a request, what happens is it associates itself with a unique ID, right? It can be a UUID, which is guaranteed almost every time it will be unique. Then that unique ID is within the scope of the application also, it is passed to different circles. Like you can just place that particular ID in the heap, and anybody who wants to refer to it can typically refer to it from the single heap location that it has added. To pass it to external application via HTTP call, there is a REST template, like there's a REST guideline. You can place that particular header inside. You can place that particular value inside the headers, so that my dependent application also knows what is the request that I'm trying to process. And that is how every system, it can be 50, you can be calling 50 different microservices or services, right? Even then I have one ID. As soon as I go to my logging framework and I encounter an exception, I can just check what is the ID associated with it, and I can draw the entire set of how the requests flow through my entire system, and that is something that typically very speeds up your debugging process to a great extent. Yeah, these were the top three things that were coming to my mind initially. Uh, let's go and see how problem changes when it comes to scale, right? Scale brings in a lot of different challenges in itself, right? And scale have different meaning for backend and for client as well, right? Scale for backend means that uh, earlier my system was catering to, let's say, 10,000 users, but it shoots up to let's say 100k users or 1 million users or maybe 10 million users. And if you're at a Facebook scale, maybe a billion users as well, right? So varying so scale basically varies for backend and frontend. So obviously the way of handling the scale also differs, right? I'll start by talking about a little bit on the backend, how it is handled at backend, and then I'll let Arnav talk about how we can manage it on the front end as well. So, as I said, on the back end, when the requests are increasing, right? So, if we all know, to one single system cannot handle all the requests that are coming to it, right? So we try to scale it horizontally. How do we do that? We place all the instances behind a load balancer, and if the need comes that there isn't a lot more scale, a lot more other users are also coming, then we typically uh, add more instances behind the load balancer, and that's how we scale the application servers, right? There is a scaling required of the database layer as well, which is stateful scaling. Uh, the one that I just told you was primarily on the load balancer side was primarily a stateless scaling. The benefit of keeping my system stateless is that so by the way, state if you guys don't know what stateless and stateful means, the difference between the two is that data one liner difference is that the data, if it is stored within the instance, it is stateful. If the data is not stored in that particular instance and that is only used for compute or maybe calling multiple services to club the response, then it is a stateless system, right? So in when it comes to scalability, it does make sense to keep your system stateless. Why? The routing becomes very easy, right? Whenever there is an increase in the load, you can just go to the you can just go to the load balancer and add more instances, and your system will run, right? The reason it will be able to run is that there is no data which is stored, right? We are only using it for compute, so it will be able to scale much faster and have a automated trigger built in, right? When I said in the beginning that have some monitorings and alerting set up, and if the disk is getting full or CPU is getting clogged, you can add or remove more instances. When it comes to automated scaling, and when you are talking about a scale where you have millions of users, it becomes absolutely necessary to rely on automated triggers, because you will never know, or humans can make errors, right? Maybe you have deployed a person whose basic job is to look at the metrics, and if the metrics is spiking, he adds 5 instances to it. Now, the kind of errors that can come up here is that the person can come back to me and say that, hey, I forgot about it, right? मैं तो भूल गया, मैंने चिल ले लिया, या फिर मैं कॉफी पीने गया था, I forgot about it. So to avoid such human errors or negligence errors, we should have automated triggers, and the kind of instructions or the kind of rapidness that comes with having automated triggers. Manual process cannot match that. And using that, we can basically set up that, hey, if my disk is 80% full, add attach one more volume to this particular ECU instance. If my CPU utilization is going beyond 70%, add one more instance, right? So these are basically strip functions, and maybe you can have a max count that do not increase the count beyond 100 instances or 150 instances. Uh, So this was one point. I'll come to more points, but I'll let Arnav also talk about the scalability challenges that typically come up in the client applications.
Right, right, right. So no, this is a very, I think, challenging space to work with, and I think there's also a lot of misconceptions. If people have not worked at scale, then when we talk about scale for front end, people have a lot of misconceptions around this. Not front end. The thing is that scale works in a very different way. Um, by the way, like there is a famous story that WhatsApp had, I think, some 500 million users when it was getting acquired, and they had a team of only 19 people, entire company. I think, as far as I remember, the news story that broke, 19 people, not just front end team. I'm saying a whole of WhatsApp was 19 people, 19, 20 people when I get acquired. Um, so how were they able to do that? And does that mean that if you have 500 million people, you can always run with a 20 people team? Some companies might have 200 people team also at that scale. Now, what happens with front end is that the scale is more about the variety of scenarios in which your client is running. It obviously is not so directly dependent upon how many people are running, because at an individual level, the front end is always running on one device at a time. So if you have 10,000 users, if you have 10 million users, your front ends, each instance is only running on one device. But what starts becoming challenging is that say there is some particular random laptop on which some particular very not so frequently used browser, inside which a certain say CSS thing does not work. Or similarly, there is one particular Android device made by some particular manufacturer on which background services don't work. Now, if you have 10,000 users, maybe two people are affected by that, and it's a rounding error. You check it. You say, I think two people will not be able to use it. What can I do? But then when you're 10 million kind of audience, and there are two things can happen. One is obviously just extrapolating from that, from two people, it becomes 2,000 people and all. But more than that, what happens is that uh, because the audience has increased, now you get a lot of people. So from my experience, I'd say Zomato was that as we expanded from top 20, 30 cities of India to 500 cities, we found people using much lower end devices on much worse internet connections, right? So then we have to cater for many more types of environments in which the app is end up going to run, and that becomes the challenge of scale at that point. That what was a corner case, at 1/10 of that traffic. Now it's not a corner case anymore. It's a pretty significant problem for us now. So that's there. The other part about scale is that your backend can only suffice in terms of performance up to a certain level. A lot of the points that Mohit you were saying till now, very helpful. And as your backend partners for when you're making the app, or whoever is your API partner, community partner in your team, they are going to be doing a lot of effort. They're going to be putting, making performant and all. But beyond a certain level, you will have there will be limits that you reach at the speed of the query and the size of the data that you can fetch. So then you need to add some client side augmentation for that. So paginated API requests, API layer optimization, where the client can sort of fetch only the part that is shown in the screen first and delay loading the later part, so that the server does not have to send you maybe a list of 50 items. They can send you a list of 10, and the list of 40 can be loaded later, something like that. These things come. Then there are, I think, a little bit more just touching upon is like BFFs start coming. So BFF, for example, at my most recent workplace, which is Target. So there, a BFF is the front end team's responsibility is actually maintaining a BFF. A BFF stands for backend for front end. Now the backend itself has a bunch of microservices. The listings detail of products is coming from some place. The order detail is coming from some place. The user account details is coming from some place. And then the app team basically creates a middleware server which collects them together and makes one single response that becomes the homepage response, so that the app can make a single response homepage API. Now, what happens is, for example, in client, a lot of slowness also happens out of the latency rather than actually server's transaction speed. Maybe so for showing the same page, for showing the same data, if you're fetching it from 5 different places, the latency of each API hit also adds up. There's going to be 150 milliseconds of latency that will get added up if your server is not, edge is not in the same country. If the edge is in the same country, then 20-30 milliseconds will get added up for every API transaction that's happening, right? If 5 API calls have to happen and then only you can show the data on your screen, then that 5 into latency won't be able to sort of prevent that. Right. Now, that's the place where something like a BFF can help, that it will do the aggregation at a server level, at the edge level itself. And then from edge to app, there is one API call. So latency is only one time. Then there is also the scale of features, which I say. So scale is also about features. Now, too many features are there, too many pages are there in your app. The team that you're working on becomes big. There you have to work on scale, is that you split your team in terms of features or different user flows. And then you do something called client sharding. Very hard to do actually. Basically, you divide your front end team, and then they take care of different front end parts. And in terms of front end frameworks, there's a concept of micro front ends, that you develop features of front end very independently, and then they can be plugged together. And similarly for iOS apps, you create separate frameworks. Android apps, you create separate graded modules, which together become the app. I have some friends, for example, who are at Gojek. It's a very popular example of something called a super app. So they have bunch of uh, completely end-to-end user flows, etc. Food delivery to shopping to like in India, there are a lot of different apps we use for different things. In Indonesia, many people use Gojek as a single app for 10 different use cases, for which we all have 10 different apps. So there they develop it like 10 different apps, and then they compile it together into one package and they distribute it as a single app. So that's something that comes up. And then finally, in terms of design, is also very important, is that having a cohesive design across the entire app. What happens over time, bigger teams, they generally start having a separate design team or a design platform team, and they create your dictionary of components that you use to build the front end. So, you know, how the button would look like, how a card will look like, how a checkbox would look like, how your input forms would look like, how your page animations would look like. They need to be same across the entire app. So why should every team working on every feature put effort into that? Instead, you create a very atomic design toolkit that, okay, smaller components, one common team will build, then every feature team will pick those components and use it in different places. So yeah, I think these are some of the steps that you need to keep in mind while your front end scales.
Right, right.
So I think
Uh,
next question that we have, I think
Uh, I,
is
I'll add a couple of points on the
sure,
same
sure, sure.
question.
Yeah, go ahead, go ahead.
Yeah. So the point you mentioned about client charting, right? I wanted to give one anecdote that I typically I saw in Hotstar, right?
Hmm.
We came to a point that our backend teams was like, "हमने हाथ खड़े कर लिए," and I can't do anything now. And it was up to the client team to assess the backend teams to have the scalability. The use case was that if you saw play and watch, right, you can just watch a cricket match and guess the outcome of the ball. It was basically a game within a particular app.
Right.
There we were basically calculating the score of every user on the client, and after the end of every over, initial design was that once the over is finished, then the client team will basically fetch the data from the backend, and that is how we're going to be using it. But what that led to is after end of every over, right? So that event is same for every user who's there, who's basically watching the match. and that led to a huge spike in the whenever the over ends, our backend server was bombarded with multiple requests, and throughout the over, there were no requests. So that is where we assigned a ID to every client, and we said that, hey, modulo 10 is what is the delta. You're going to add. Uh, that is basically a delta delay that you are going to call after 1 second or 2 seconds or 3 seconds, and that
Hmm.
is they'll continue doing that. So what we did was we reduced the load on the backend server by 1/10. Uh, right. So that is like that really clicked me when you said client sharding. I don't know if I've
Yeah, actually,
used the
we
client
did
sharding.
something similar at coding blocks as well, at
Yeah.
a much lower set of scale itself. But the problem was like, I mean, we did not have sort of auto scaling kind of a thing where servers can automatically increase in number when the load comes.
Right.
We used to conduct some of these scholarship tests, and generally like the backend is running, code is getting judged, even like 2 3 requests per second are sort of coming, and these are heavy requests, like entire
Right.
code is getting submitted, test case has to run, right? So already a lot of servers are running, but then when the scholarship test happens, then first of all, the people who sort of like want to start the test, that usually like suddenly 50 60,000 users together want to start the test, and that's a very different scale from at any other time there are only 200 300 users online, and here 50,000 users will start, right? There we used to do something similar, that we used to divide people into buckets, and if the test is supposed to start at 5 p.m., then for 1/10 of the people it will start at 5, for next people it will start at 30 seconds later, for the next 1/10 1 minute later, like that we used to distribute that. So yeah, these kind of hacks are sometimes needed, because there sometimes it's like either there is a physical limitation itself on the backend that you just can't scale beyond that, and sometimes it's like a prudent call on your end, like why set up 20x more
Exactly.
servers when you just need it for that one spike. You can probably distribute that spike a little bit more. So like
Exactly.
people were saying flatten the curve for that coronavirus thing. It's kind of similarly like that. If your capacity can't handle such a big spike, then flatten that spike during that time.
That's right. That's right. Cool. So I'll add more backend points that you should consider when you are scaling the application. So I already spoke about keep your server stateless, set up infrastructure for that supports auto scaling. Next point is very critical for auto scaling perspective, right? That is that you have added a stateless server, but when you add a new server, what are the typical things that are involved? One is the OS should boot up. After the OS is boot up, the app server itself will take some boot up time, right? So if you start a Java process and run something like Java minus jar, then you run the process. It also takes some time. It will start up a Tomcat server if you're running a Spring Boot application. It will start a Jetty server, or maybe a Underta or Netty, or basically some server which is able to communicate via REST APIs. So that also will take time. So keeping or choosing a stack, especially when you are dealing with millions of users, choose a stack which has least amount of boot up time. And instead of booting up instances, try to Dockerize or containerize your application so that launching a container is much faster than launching an EC2 instance on AWS, right? Or maybe launching a new server in itself. So keep that in mind that your boot up time should be as minimal as possible, right? Then another thing that we need to scale when it comes to scalability in the backend system, especially when you are trying to scale your databases, is the read. So databases does two things, right? It support read queries and it support write queries, right? Delete update also comes in the write part. So when you are not able to, let's suppose you are designing a system which is write intensive, in those cases try to shard the data so that you have multiple servers keeping the which are basically needing meeting your storage requirements. But the other kind of problem that comes up is the read as well. Let's say you have stored the data at one place, but the number of reads that you're getting are enormous, right? For example, Aadhaar data. Right? Once you've entered the data, many times it will be read multiple times, but updates are going to be very less, right? Or maybe creating a new Aadhaar will also be a very less frequent job as compared to reading it. Similar is inventory showing on an e-commerce website. Your inventory is fixed, but the number of users who are reading that particular inventory are huge. So what you do is you create multiple copies of this particular data and keep it at multiple places. Uh, there are 10 servers who are keeping the exact copy of the data, and whenever the request comes to your application server, all the 10 servers are basically capable of returning a valid response. So replicate for read scalability and shard for write scalability or write throughput. And whenever possible, try to add a queue whenever you are having a batch operation, right? For example, if you have to, let's say, calculate monthly payroll of employees, that is a batch process, right? You don't have to
Hmm.
calculate the payroll of every employee every time, right? It's after maybe at the end of the month, it is a batch process, you'll run it and then you're done. In those cases, you don't have to, let's say if you have 200 employees and your servers can process only 10 requests per second, you don't need 20 servers, right? You can live with maybe one server and process it. Start the process maybe on 30th of every month, and by the end of the day, all the 200 employees will be processed. So try to utilize workflow systems and queues for having such kind of scaling challenges. So yeah, those were a few scalability tips that I wanted to add. I think next question is also very interesting, which will give you an idea about what kind of tools that are quite essential when it comes to debugging a particular application. Uh,
Right.
so no, I'll let you answer this first, and then
Hmm.
I'll come back.
So tools, I think one thing I feel actually a little bit off with front end is that there aren't a lot of actually very open source tools in as such for monitoring and all. Sadly, the current state of how open source software is like for example mobile and all, it's mostly common is that people are using Firebase now. Firebase has a lot of things inside that. So when I say Firebase, I don't mean entirety of it. So Firebase has got database, Firebase has got push notifications, bunch of things. The Crashlytics, which actually used to be a separate service, got acquired by Twitter. Then like that whole bundle called Fabric was acquired by Google. So it has a long history. But it's a fantastic tool for crash monitoring. So that's there, and then there are a few other tools as well, which like Crashlytics is very Android focused, but these days iOS is also using it. In most big companies, Android and iOS native apps would most likely be using Crashlytics. But Sentry and Bugsnag I have seen also getting used a lot. Right. Sentry essentially is open source though, and it's available as a Docker container. You can run it on your own server as well. Sentry does get used a lot, which I have seen. And then uh, there is for application monitoring, there are a few tools that are there. So Datadog and New Relic kind of tools get used. I have seen. One more important thing is that along with these tools that we need for debugging and monitoring and etc., we also need a little bit of security side tools as well with our apps. So code obfuscation and encryption and these things. So using things like AppGuard and ProGuard, which basically obfuscate your code, or when you're using something like web front ends, mostly your bundlers, which is like Rollup or Webpack, those will automatically also do the same thing for you. So those are not like some bulletproof security measures. They work on security by obscurity, so that your code does not really remain much readable anymore. Because most front end setups are such that you can't really make super hidden code, binary level, which you compile a C++ program, it becomes a hex file. You can't really get back to the original C++ code at all. With frontend, what happens is, you can sort of decompile bytecode of a Java app back to some kind of Java source code. And with JavaScript directly runs on the browser. There is no source code and production code. So their obfuscation kind of methods are the only way to add some security there. So yeah, I think that's sort of the things that are there for front end. I think what do you use for monitoring, telemetry, uptime, and all, alerting, and all? What tools do you use for backend? Any ideas for that?
Sure, sure. So I'll structure my content like what tools are required for monitoring and maybe distributed tracing and for alerting, right? And what are their uses. So for monitoring and alerting, the major tools that I typically use is so I'll talk about the open source first, and then we can talk about the paid ones as well. So open source in the open source code, Elk-Stack is something that is very famous, right? Elk-Stack is Elasticsearch, Logstash, Kibana. You can push matrices to Elasticsearch and have a detailed monitoring of all the components. If you just want to push logs and search based on logs, that is also possible using Logstash. There is FileBeat, which will periodically look at the logs that are getting added to a particular file, and it will push it to Elasticsearch. And Kibana is basically used for dashboarding and if you want to visualize the data and maybe set up alerts as well. These alerts are not that great. What I typically use, specifically use for alerting, is uptime, which will give you a very good status about which services are up and which services are down. It works on a health check kind of a URLs. For example, if a particular API is down, or if a particular service itself is down, its health check will fail, and we'll get an alert for that. For alerting it to so the uh, other variants that you can typically use for visualizing the metrics, let's say you want to measure the latency of a particular function. In that case you can use I forgot the name. So you can use Grafana and Graphite for basically visualizing, and you can use StatsD for sending out the matrices. Let's just annotate or write a aspect which will measure the latency of a particular method and push it to StatsD. StatsD will you can integrate StatsD with Grafana for visualization, right? So every developer who's basically developing it, right, and wants to work in a open source kind of a setup needs to know this tool, right? These are the de facto student regardless of what kind of microservices you are building. If you are working in a company which is which has a lot of fortune and you are willing to spend it on tools, then good paid variants would have Splunk. There is New Relic, there is App Dynamics. These will, in fact, give you the memory profile of a particular server as well. So let's suppose if your application is running into 10 servers, it will list down all the 10 servers, what are the memory profiles, what are the objects that are getting passed, what is the latency of each server. It will raise alerts, alerting and monitoring both. It will take care. It will also integrate with other paid tools, which can basically give you a call if a particular service is down, right? So most of you would have heard about on-call duties in Amazon, right? So the funda of on-call duty is that one person will be available 24/7 for a certain period of time. So funda over there is they'll get a pager duty, they'll get a call, they'll get a Slack, they'll get email, they'll get bombarded with all the on all the channels, and if there is any error that is not noticed. So that was basically around error monitoring and alerting. Another important aspect that I touched upon initially was around distributed tracing, right? And I think there is some question around that as well. So I'll just highlight that. So what should we use for distributed tracing, Jagger or Zipkin or So what I have used is I've used Open Telemetry and Zipkin both. Both of them I've not used Jagger, so both of them are good. Zipkin is primarily Java based. Open Telemetry is a polyglot system. That means that you can use it with Golang, Python, uh, any language, right? It works on the HTTP standards, not on the Java standard. So you can use Open Telemetry for that, and yeah, so those were primarily the tools that I use for my monitoring purposes. Any thing else that you want to add, Arnav, before we start taking questions by our beloved audience?
When talking about tools, another thing I feel is that your development time tools are also very important to have. Like one is that in production, how do you debug and how do you find out things and all. One thing I'd definitely like to point out is that for front end, actually, when things really go wrong at that point, there is very little to do because for web front ends, it's already cached with the user. You can't, like that redeploy front ends everywhere and people will get the new website. That does not happen. With apps, it's even harder. Actually, your deployment cycles are generally 2, 3 day long. So even if you can fix it within 5 minutes, you put the app on the App Store or Play Store, they will take 2, 3 days to review it. And then the user ramp up is also going to be very slow. So something like on call, like you were saying, and that actually sort of triggered me to say this, is that in front end teams, you will never have somebody on call because there's just no point. Like, what will the on call person even do? They can't fix things. So being able to sort of monitor, replicate, and fix a lot of the issues at the development and debugging stage, then essentially becomes a lot more important. And kill switches become also very important in terms of front end. So basically, the ability to sort of like most bigger projects that I have worked with, they generally do is like say when the app boots, whether it's a web app or whether it's a mobile app, like boot up being in terms of web app, generally when a SPI hydrates, like your API, your web request is made, the web bundle is downloaded, and like websites like Facebook, Twitter, and all these are actually like essentially like apps running within the browser these days. When they boot up, they would do is they would make a configuration call generally to the server, which would tell them that okay, say for example, a certain service is not working, the server would send an appropriate response, as a result of which that particular tab will get disabled on the front end. Those kind of things also need to be in place, like being able to have fallback mechanisms, and being able to disable certain services as well based on some configuration requests in the beginning. That's important to have in place because if something is actually sort of crashing, then it's very hard to kind of resolve that and then get a fix in place and deploy it and get it adopted very soon. What is possible is to prevent people to get to that place where that crash is happening till this happens, and you need to have systems in place that can probably do that.
Right, right. And I know that, man. I faced similar problems, and like we can't really do anything if something goes wrong in the client side. So,
Yeah, yeah, yeah.
kill switch is the only thing that we can do. Cool. So we'll start taking questions from the audience. Right. We'll
Right.
start in the same order. First question is by Rahul. We can configure rate limiting on the API gateway. I guess he's basically referring to the first example that we said, right, where the load on the system is getting really high, and we can typically add rate limiting. I think we are. I'm aligned with that. We can do that. Just that if you add rate limiting, and because of rate limiting, X number of requests are getting failed, keep an eye on that as well. So if you're rate limiting, maybe you'll send a 5xx error, and keep an eye on the 5xx error also. It should not be that more than 5% or 2% of your errors are of your requests are actually getting rejected because of the API rate limiting aspect.
And I think to
or
add to that, the rate limiting can happen at multiple layers.
right.
Like from my experience with Zomato was that there was a sort of rate limiting logic on the clients itself. Then there was rate limiting logic on the edge, and then there was rate limiting logic on the application layer. So on the client, actually, what kind of rate limiting happens is that we are tracking a lot of user metrics, like everything, like a person is searching, opening a restaurant, all those events are going. These days, every app collects a lot of data about you. It helps them, give you more curated responses and all, right? Now, this data that's collecting, it's all going into a data engine analytics server. It's going right now there. If for example, the last chunk of analytics, if I try to upload and it failed, for example, then it will retry 1 second later. If that also fails, then the second retry happens 5 seconds later. If that fails, then another retry happens 10 seconds later. Like that, it's a throttled retry happens. Now, that is there because the API where the sort of logs are getting collected, somehow if that's clogged or something, then we don't want all these 30 40 million active Zomato users to sort of DDoS our own server if the logs are getting clogged. So the client should throttle back. They should, if they're not able to send the request, they should slow themselves down. Those kind of. So that's basically like a set of a rate limiting that's happening on the client side itself. So there's multiple layers where you can add that rate limiting logic.
Makes sense. Next question is by Jasurya. Where do you think routing should take place in the front end or back end? So any kind of routing that we do on the client side, then we talk about the back end.
So I think here he's talking about probably SPAs versus MPAs kind of a thing where single page applications and multi page applications are there, where sometimes the routing is actually happening on the like appear to happening
Mhm.
on the URL bar, but the page has not actually been refreshed. Just a
Mhm.
AJAX call happening and data is getting updated. But in either way, like even if you're doing what is essentially called front end routing, in that case also like at an API level, you need separate routes from where the data is getting fetched.
Correct.
So your backend will definitely have routing. At
Yeah.
front end, you might have like front end level routing via an SPA, or you might have a more dumb front end which does not handle routing.
I think one more aspect to his question is that I think this question popped up when I was giving the example of designing homepage for Netflix, where
Hmm.
I was supposed to call multiple APIs. So
Right.
from that perspective, I think this question lies. So backend way, obviously, you can do such kind of routings, and we can talk about the trade-offs. Uh, so this is kind of that scenario, BFF, right? Backend for front end kind of a scenario where you're
Right.
calling a single API, and that server is basically routing the request to multiple servers. The
Correct.
benefit that you get out of it is that I can dynamically change the places where I'm fetching the homepage for. Right, from a client
Right.
perspective, you just have to call one API, and that will fetch the entire homepage content for you. But if you do it at the if you give this particular logic to the client that hey, to render the front end, call these 10 APIs, and then render the then render the client, homepage. The downside of this is that this particular logic has to be implemented by every client, right? In Hotstar, we had 10 different clients, right? We had iOS, Android, Fire TV was there. There's PlayStation, there's mobile web application. Then there is the website. So there were multiple clients that were there. So if we give this particular responsibility to the client, every client needs to do it in a uniform manner. And typically, clients team are different. Right? You'll have separate
Right.
set of team for iOS developers. Separate developers will be working on and making the Android app, and there will be single developer for less prominent devices like Fire TV or Roku TV. So bringing them all the different teams on the single page also becomes a operationally challenging task. So if that's the case, it makes sense for a backend. Happy to hear your thoughts also. If you have some of the thoughts around this.
Yeah, I mean, apart from having to implement in every client, it's also that client logic is harder to update because some of the clients, like if it is a like as you're saying, if it's an app properly, like an installed app, whether it's a mobile or PlayStation, Fire TV, these kind of
Yes.
cases, then the user has to update that app to get the new logic as well, which is a challenge in
Correct.
terms of user adaptation. You have to support pretty old versions, right? So that is also a downside. Like when you want to update the logic, you can't immediately get 100% of the users to the new logic. That's why a BFF
Right.
is much better in that perspective.
Yeah. Makes sense. Makes sense. All right. Next question is by Damoy. Hey, what about setting up staging and production environment for an Android app? I'll let you answer this.
Yeah, I mean, this is a very common practice, of course. Like you should have a sort of uh, you have the production, and then just beneath the production, usually something that people call the UAT, user acceptance testing, we call. UAT environments are sort of one is to one equivalent to production, but they are not used in production. They are used in staging. You can call it staging or UAT. Now with UAT kind of environments, essentially, what also is often done is that in many places, like there is going to be a debug build of the app and a prod build of the app. Now, the production build would generally point to the production server, and the debug build would be pointing to your UAT servers. So you're sort of mapped out in that sense. And then you might have even further. What we used to have is we used to have team level stagings as well. At Zomato, we had that. Is that every team also had their separate staging servers. So if they are working on a new feature, then in the app in the app which points to the staging version, there used to be like a hidden screen basically which you can't reach on the production app, but in the debug app you can basically reach on that screen and you can change the staging server. You have 10, 15 staging servers. You can use a different staging server on which maybe a new feature has been enabled, but it's not enabled to the production yet. So you can point to that server and then test those features out. So those things should be there. Like you should have a proper end-to-end environment setup where a debug version of the app, pointing to a debug version of the BFF, pointing to the entire debug suite of your UAT or staging suite of your servers. You should have as your sort of organization scales, you would end up having a full end-to-end setup, exact replica of your production in staging as well, which you can very safely test it out.
Makes sense. Next question is by Manish. I think it's for you, Arnav, again. Android app performance pro tips, please.
So I think covered some of those there. I think it really comes down to using the profiler very well in your Android Studio is very useful. Keep track of memory issues and CPU spikes and all. So use the Android profiler. Not a lot of people use it properly. So just connect that to your phone and run through your debug build once through all the screens and see where there are CPU spikes. Then you can sort of generally double click that, it expands and it shows which threads were doing too much work at what point of time, and it shows which methods in your app are running as a result of that. It's a fantastic profiler. And then if you're using Java on the backend, the IntelliJ IDE and then Eclipse, those have also very good profilers. And similarly, if you're using Android, then these profilers exist. And iOS also similarly export as profilers. So these tools like profilers exist, and you should definitely use them to their best capacities. You know, Apart from that, other than that, pro tips would be general good development practices. Obviously, right? Having a understanding of the low level design patterns, right? Like where you're doing something like a dependency injection, you're using a singleton, and some memory leak can happen because of static scope is getting you know uh, removed there. So those things, obviously, low level design, having robust idea of low level design is very important. People who are good with low-level design, they generally produce systems where performance standards are much, much high.
Right. I think profiling is important for any development you do, right? Be it backend development also, to measure the performance, how much your one machine can handle, right? For that, profiling is important for backend as well, and that will give you a very good estimate about how many actual amount of data can be there, can be there in a particular application in a single server. Right. Cool. So we move to the next question, which is what tools would you suggest for a backend, full stack developer? The follow up is that he means technology that we suggest. So I think I'll tell my favorite, and then maybe you can jump in, Arnav. So
Right.
I think here, if you don't know any language, right? So primarily, I think you can learn JavaScript because you can typically write front end in JavaScript. Plus, learning Node would be easier for you. Mean stack is getting quite famous these days, right? So have a knowledge about MongoDB that will give you a knowledge about one database. Then Angular will teach you. Angular will basically again a flavor of JavaScript, so that will also give you a. You'll be able to design web applications using that, and then Node obviously for backend development. Yeah, that will get you started. Now, this is not for a good scalable design, but you can develop an MVP in my opinion.
Right. Right. No, I mean, I concur. I think I also generally suggest like for people starting off, I sort of blindly suggest Node.js because you know same language using that you can build, and to a reasonably good scale you can build as well. I mean,
Yes.
there is a certain point you reach, maybe sort of switching to more performant language like Go and Rust and all, and can come into the question. But to a very reasonably high scale, you can work with Node.js. It's a good language, and there's the same thing. Like the advantage of using the same language on backend and frontend is very, very good.
All right. Abhish is asking about AWS skill resources. I think one of the best way to learn about AWS is start, apply for a AWS free account and start playing with it. Right. That's how I learned it. And whenever you're stuck, right, AWS has a very good feature. There's a question mark after every step you are taking. Right? So, for example, when you create an EC2 instance, right, it's quite intuitive on the UI. You click on EC2 instance, it will launch an EC2 instance. Then it asks a bunch of jargon terms that initially I didn't understand. For example, it will ask for you ask a VPC information. Now I don't know what a VPC is. So there's a question mark around that. Once you click the question mark, you'll be landed to the official documentation which explains what a VPC is. So that is the best way to learn, right? It will give you a practical exposure first of all, and it will also point you the. It will always be an updated one. If you follow any tutorial or something, chances are that it might not be the updated one, right? And you'll only on a tutorial, right? One of the things that I typically face is that they are not quite up to the date with whatever is the latest offering, and you're gated by whatever he's teaching, right? You learn only what he's teaching. Whereas if you learn it, on a self pace, you'll try to dig deeper and understand it, in all the breadth and all the depths that you like. So uh, those are the resources that I would suggest you for AWS. Uh, all right. Swarna says you spoke about staggered spike handling, but say you don't know the number of users beforehand, and the number of users are increasing faster than the time taken for to be added. Balancer, how do you scale? The answer to that is you cannot scale that. Right. This is one problem that I have faced a lot. Trust me. And the only thing that so how we handle that is that we AWS provides you one metric to scale on, right? That will basically give you those metrics would be static metrics like 70% says other CPU utilization, so add one more instance or add five instances, but boot up time would go for a task. And this is exactly what happened. What actually happens whenever a cricket match also starts, right? So IPL starts at 8 o'clock till 7:50 or 7:55. There are close to 1 lakh or maybe max 2 lakhs user on the platform. As soon as the match starts at 8 p.m., this quickly jumps to 10 lakh or maybe 15 lakhs or maybe 20 lakhs users. So there's a 10x jump within 5 minutes gap, right? So the time to scale up those instances in this amount of time is very less. So if we just rely on the infra identifying this and then doing it, it becomes problematic. So the first thing that we did, the first solution that we had was to predict the users. We thought that predicting is basically the best we can do, and we over provisioned a lot, right? The second version was basically to take a derivative of the number of users, and that will give you a slope. If the slope is very steep, that means instead of adding one instance, I'll add 10 instances. So the slope became the deciding factor of how many instances I'm actually adding after a certain time. So if I add 10 more instances together, instead of adding one instances one by one, uh, that becomes problematic, right? One instance, again, my CPU load is high. It will take some time, its own sweet time to add more instances. The third thing that we typically did was we moved away from EC2 instances to Dockerized containers. The reason is that now I have free, CPU. The OS boot up time is basically lower, and we switched from Java to Golang because Golang boot up time is way faster than a Spring Boot application. Spring Boot application was taking around 40 seconds to boot up, and we didn't have that kind of time. We cannot afford that kind of time. Right? So have a different set of instances and tech stack if you have to handle for spikes. And lastly, the solution that is running right now is ML kind of a model which predicts how many users are going to be actually there on the platform. And if its prediction is right, we will be able to handle this spike. If not, we'll rely on the slope. So that's the best that I know. If you have anything better, please educate us in the comments as well. Uh, cool. Uh, I think this is what issues are the hardest to debug. Any specific category from experience at Hotstar? I think this is also. I think the most difficult issues are the issues that do not give any exceptions, right? So typically, if you have to deploy something, and let's say it is you released a feature and you're not getting any exceptions, you're not getting any to everything is working green in your monitoring dashboard, right? And chance and if that gets propagated to some propagated to a client, maybe I misplaced some spelling mistake, because of which that particular API is not even getting called. There are two versions. If my client teams are calling the older version, there is a new version. I'm thinking that my dashboard is clean and everything is working fine, right? So those kind of issues where I don't get the exception stack trace, or I don't have, I don't really know which method is basically causing that particular issue. Those are the hardest for me to quantify or to give you more context on this. Uh, let's suppose I'm debugging a slow API. Debugging a slow API is, to me, the hardest problem. Right? It can be, and the issue can be anywhere. Right? It can be either due to client network calls. It can be a part like 80% of the users. For 80% of the users, it is running fine, and for let's say 20% of users, it is not in the accepted range. Then it might be a server issue which is running that particular application. Then I'll go back to server, look at the logs in the server, and then try to debug it. So I think that is to me the hardest kind of issue to debug at the backend side. I let Arnav speak his thought around the client sides. What do you think is the hardest
So
kind of
actually,
problem that?
the thing you said about exceptions not coming in, that is obviously the hardest. And one of the things I used to like as a team lead, as to be sort of a Hitler about, is that people often like, for example, specifically saying say Kotlin code, is that uh, for null safety you can use two approaches. Like, either you crash when you face null safety problems, or you know you wrap it around in a null safe wrapper or something like that. No, no, in code reviews and in team discussion, everybody has to say them that, dude, exceptions are great. Like don't try to achieve for a lower crash free rate. Uh, like a lot of time when you're coding, you're thinking, oh, like our app's crash free rate should be 99.9999%. And for that, wherever possible, I will try to sort of eliminate exceptions from my app. And I used to tell everybody, like, never keep your objective to eliminate exceptions, because then you will start getting bug report from a user. Well, they will say, I open a screen, it is white, I can't see anything. And then you won't even know where to start figuring that question out, because you did not get a crash report. Crash reports are the best thing to start with, because you get a stack trace. You know exactly what problem happened. So hardest to debug always is where there is some undefined behavior happening, which when you mentally dry run your code, you see there is no way to reach such a condition. But there is no exception or no crash to actually track that. So now you're sort of hunting in the dark, that how the fuck did this user reach this particular scenario? I don't know. But there is no stack trace on my Sentry or on my crash lattice to even go by. So I think when you're coding, wherever I would say one thing I used to say, a part of defensive coding, I used to tell them, is that wherever sort of you're writing a lot of cases that, if somebody submitted an address, if the length is too long, or there's a special character, or the pin that has been dropped does not, the geofence does not match with that address. So many use cases, say for example, right? Now you're writing a if else and a switch condition, maybe a bunch of logic you're writing. A couple of places where there's some undefined behavior is possible. Like, and I used to tell them that wherever in doubt, what to take when I have reached this particular branch in my if else condition. Wherever in doubt, throw an exception. That's the best code. Like if you write throw some exception in your code, I would definitely review that, merge that code, no problem. Because throwing exception is the best thing to do, because then it's just so easy to identify the problems and solve them.
We should not fail silent. Whenever there is an exception, right? Just print the stack trace or push it to some queue so that people who are debugging it they
Right.
can look it into it. What I typically see in I've seen this particular mistake made by a lot of people, that they do try inside a try block they try something, and then in catch exception, and instead of catching the specific exception, also this called the superclass catch exception EX, and catch blocks is completely empty. So
Yeah, nothing
now
is
I
done
don't
in
know
the catch
what is
block. Yeah.
happening. So nothing is done. So in that catch block is completely empty. So we will not be able to figure out where exactly
Yeah,
this error is coming
you
from.
neither get the exception, and the user is in
Right.
some empty state where nothing is happening.
Correct. Yes. Yes. So yeah, that those kind of bugs are hardest to debug, I guess.
Right.
Okay, we'll take one last question. So we intended this session for 45 minutes, but I think we've well past that. We'll take one last
Yeah.
question, but that's by Saurabh. This is for you, Arnav. Some love from your fan.
Okay. So you want to become a mobile application developer, you're doing native Android dev and a little bit of iOS. Is it a good idea to switch to Flutter or React Native? Uh, if you're good in native development in either Android and iOS, and you can pick the other one a little bit, then I would say there is no point spending time on any hybrid framework, because today the demands for native Android and native iOS developer is going through the roof. Hard to find good people, at least at senior positions. It's very hard. Hiring for native Android developers, good quality, used to always be a challenge for me. Uh, Hybrid apps have their place, but even at scale in big companies where hybrid apps are also used, companies which rely on Flutter or React Native, they would have quite a few people on their teams who would be working on native as well, because they need to do bunch of the stuff in the app in native and sort of glue it into their hybrid code. And hybrid code is still sort of getting used in some startups a little bit. Agencies use them a lot, where the the engineering of the app is not so important. It's like more content-based apps are getting made, like a app for a conference. So for that, it's a more visual kind of an app, not a lot of deep down native stuff happening. You can make it in Flutter, that's fine. But if you take the top, I think top 20 apps on the App Store for both Android and iOS, right? A top 20 in terms of downloads or top 20 in terms of trending or anything, you will find 90% of them are native apps. There will be rare conditions like Instagram is there because obviously Facebook their own framework React Native they're using. I find Instagram on Android, by the way, quite buggy. In fact, there are a lot of places where there are some bugs. On iOS, it's a great app, by the way. But that's how React Native is designed. React Native was originally designed to work well with iOS. Android support they added much later, which shows up in even their own app, I've seen. So, native Android, if you're doing well, and then iOS you're able to pick up, then I think you can stick with those things. That would be best.
All right, all right. Thank you so much, Arnav, for taking time and
Yeah, yeah, yeah.
session with us.
Yeah, this was very
Guys,
interesting session. I think we overshot the time a lot, but a lot of great
yeah,
discussion for sure.
right. I think people who have joined us would also have taken some, have learned something from the session. And guys, so in the session we might have spoken about multiple jargons, right? For example, stateless, stateful. Now spoke about some Android stuff as well. So we have videos on similar topics in our channel, which are recorded videos, which I would strongly suggest you to go through. We have system design series, which will give you a primer about what system, how do we scale a particular system. Please go through that. And we also have a series about how do you start Android development, right? We have a two-part series where Arnav talks about how do you start from the scratch and what are the next steps. What is the roadmap to become a good Android developer? So I hope all of you would go back and talk about that as well. Also, I would urge everybody to join the Discord group. The link we've added in the description as well, and it's right here. Let me just show it on the screen as well. Just join this Discord group, right? We'll add this particular link
We have
in
a
the
bunch
channel.
of channels. There are some fun
Yes.
channels as well. People talk about tech while playing games. People do that kind of stuff as well. And then there's
Yeah.
serious channels on Android and Java and then data science algorithms where people are talking about hardcore tech as well. So you want to discuss about scalability, about system design, or you want to have like chill with a lot of other techies and share some tech related memes. All of that stuff happens there. So definitely go there. And future events like this, when we do, we collect questions beforehand also from our Discord community. So you will get to know about more such YouTube events whenever they happen. So definitely sign up on the Discord and then reach out to us there as well.
Yes. And if you've not subscribed to our YouTube channel, please do that as well. All right, guys. Thank you so much. Bye bye.
Bye.
Bye.